Okay, here is the next video because I didn't go anywhere. Okay, so use upper real limit, upper real limit. This is the upper real limit for this 7. This is the upper real limit for this 6. Okay, upper real limit and everything below gets all of these numbers. Upper real limit and everything below gets all of these numbers. Those are the numbers that correspond to these percentages. Okay? Now, what's nice about interpolation, and let me clean this up a little bit here. Okay. We have our poles, just like we had with the time and temperature example. And with the time and temperature, we said, well, it was 1 out of 2 hours is equal to 5 out of 10 degrees. One of the nice things about fractions, I know people don't like fractions, whatever. I mean, that hopefully left that in high school, you know. I mean, this is what professionals aren't scared of. They learn how to do this stuff. Okay, I'm sorry. Well, I'm not really sorry, but you know, people want good jobs and good money. It means that you need to know your material. What's nice about fractions is it's a relational. It's fractions describe relational relationship between two numbers. So 1/2 is the same as 5/10 would be the same as what? 300 600ths would be the same as 0.4 over 0.8, right? All of these are equal, so we can equate fractions. Even when the numbers are different, we can equate them, okay? And that's what we did with our time and temperature. We found out that 1 out of 2 hours, right? 6 o'clock to 8 o'clock. So that's a 2-hour segment. We went 1 out of 2 is the same as, with a 10-degree difference, 5 degrees out of 10 is the same as 1 out of 2. Okay? So what we're going to do here is we're going to do the same thing. Oh, this is where I miss having a big board. We're going to do the same thing here. Let me move these. Let me move this over a little bit. Yeah, I'm just going to move it over a little bit. So here's our x value. Here's our cumulative percentage. Okay, 7.5 was 59.02. 6.5 was 34.43. And I'm looking for the 50th percentile. Okay. So here's what we're going to do. We're going to look at fractions. We're going to look at relationships between these numbers. So the first thing I'm going to do is get this entire interval. That is, how far is it from here to here? This is the same thing that we did with the time and temperature, folks. It's the same concept. The numbers are more complicated. The concept is exactly the same. Okay? So let's subtract 34.43 from 59.02. Let's do that. 59.02 minus 34.43 equals 24.59. So the entire distance here, the entire distance is 24.59. You have a calculator. You can subtract those numbers. That's the total distance. Okay? That's this interval, is what we call it. Then I'm going to do this. I'm going to get this fraction here. That is, how far down in this interval? How far down did we go? And we're going to go down because it's cumulative. Okay, at or below. So it's 9.02, right, this difference. I went 9.02 out of 24.59. I went 9.02 out of, remember the out of? We talked about that before. That's what division is. 9.02 out of 24.53. That's the fraction. That's like saying 1 hour out of 2, or 5 degrees out of 10. I mean, in this case, it's not half. It's 9.02, 24.5 ninths, or 50 ninths, or whatever, however you want to say it, right? That's the fraction that we went down out of this. That's what fractions are, folks. That's what fractions. 9.02 out of a total of 24.59. That's a fraction, okay? Over here, we have a total of 1. If we want to do 2 decimal places, let's do it, okay? All right? What I want to do here is go down the same fractional amount. This is now the beauty of fractions. I want to equate these fractions. I'm going to use a question mark here. Please do this because our final answer will be an x value. So I'm going to use a question mark here. So here's what I'm saying. How far down out of 1 do I have to go to make sure it's the same fraction as this? Take your time. Think about the time and temperature, right? 1 out of 2 is the same as 5 out of 10, right? Even though the numbers are different, the relationship is the same. So I want this relationship to be the same as this relationship. Here we go. Question mark over 1.00. I want this to be equal to 9.02 out of 24.59. Time and temperature, what we did is we said 1/2 is equal to what over 10? 1/2 is equal to 5 over 10. All right. Here I'm going to do 9.02 over 24.59 is equal to what over 1? Okay. Think it through. If you're looking for a rule, that means you're not thinking. And then it becomes really, really hard, okay? People think that thinking is harder than rules, and I'm like, no, no, no. It's the other way around. It's the other way around. You got to trust me on this one, okay? This fraction, I want this to be the same as this fraction. Now, so once we're here, now we can solve for the question mark. This is where people need to know high school algebra. I'm not going to be gentle about that. You need to know high school algebra to do college level work. Okay? That's the way it is. If you need help, I can help you. But we need to do that offline because this is the stuff that we're doing. However, let me show you how to do this. If you know some stuff that is other than rules, then you can make this easier for yourself. Because some people are going to do some cross multiplying and blah, 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 blah. Well, there's one thing that you should know, just as a fact, and that is anything over 1 is itself, right? So the question mark divided by 1 ends up being question mark. Anything divided by 1 is just itself. So we're going to do this. This becomes the question mark. Okay? You'll see why I'm not using x there. We're going to get to an x value. And what's nice about fractions? This is unfinished business. It says 9.02 divided by 24.59. That says 9.02 divided by 24.59. Let's finish the math and do that division. 9.02 divided by 24.59 equals 0.37. Okay. 0.37 is this question mark. That is, how far down do we have to go to do the to be at the same place, be at the same fraction? Okay. So I'm going to subtract. Let me just make sure I'm correct here. 7.5 minus 0.37. 7.13. That is 7.13, folks. 7.13 is our median. Okay. Now, a couple things. First of all, nobody reported a score of 7.13. That's okay. That is okay. This is our calculated median. Most of the time, when your professor tells you what the average for the class exams was, it's into 2 decimal places. Nobody got that particular value. It's a calculated value. This is our calculated median. Okay. This tells us that's the place where 50% of the people scored at or below as a calculated value. Okay. I will tell you where I see the mistakes all the time on exams. I can tell you where the mistakes are going to be. Don't do them. Okay. First of all, when you set up your frequency distribution table, highest number down to the lowest number. That's the only way that these things are going to work, because it's cumulative, highest to lowest. Okay. Highest to lowest. We're going to add up as we get higher. That's first mistake. If you switch that around, then you don't deserve a good grade. You're not paying attention. You're not practicing. Okay? Another thing, remember to use upper real limits. That is, I see a lot of times people say the 59.02 percentile is a 7. No, it's not 7. It's 7.5 for the reasons I described here. We don't forget this stuff. I'm explaining to you why we're using upper real limit. Upper real limit for 7, upper real limit for 6. Okay? The big mistake is people put 7 and 6 here, and you won't get full credit. You'll get partial credit for sure, but you're going to get the wrong answer. Okay? Another thing, people sometimes get to this point, and then they say, okay, my median is 0.37. Of course, what's wrong with that? Well, it tells me you have no idea what the median means. The median is the place in this distribution. The median is the place in this distribution where 50% of the scores fall at or below. If you're telling me this is the median, it's not even on the damn distribution. It's not even on there. Okay? That's why I use the question mark. That tells you how far down you have to go. How far down you have to go to get to the median. Okay, it's 0.37. What we're saying here is .37 out of 1 is the same as 9.02 out of 29.59. 0.37 over 1 is the same as this. They're both equal to that. Okay. Then you get your value. Median, 7.13. So for this data set now, we have the mean, the median, and the mode. Okay. We also have the range. We also have the highest and lowest, and we also have the sample size, or the population size. Mean, median, and mode are the 3 measures of central tendency. We know the concepts of 2 of those 3 measures. The mode is what? The most frequently seen score. The mode is the most frequent score. In this case, 8. okay? The median is calculated, 7.03. That tells us where 50% of the scores in the distribution fall at or below. It tells us where 50% of the scores fall at or below. 50% of the scores fall at or below. It's the 50th percentile. The mean, remember I said, it's a difficult concept. We haven't gotten there yet. We have not gotten there yet, okay? We will. Okay, so now here's what I want you to do. And you can take your time, and what I'm going to ask you to do, using the same interpolation procedures, I'm going to ask you to calculate the 25th percentile and the 75th percentile, okay? And I'm going to have you pause the video, and I'll tell you when to pause it. I know I got to get better with that, okay? I'm going to have you pause the video and try to do each one of these using the median as sort of your model of how to set things up. I'm going to have you do each one of these, and then when you come back to the video, I'll do each of these, and we'll see how things match up, okay? So you can pause the video now, and then when you're done with your calculations, start the video up again and see if what you've done follows what I do. So pause it now. Okay, how did it go? It's a little bit different when you're doing it, right, than when you're watching me do it. This is a very, very important message, because when you're doing the exam, I'm going to be asking you to do it, okay? Sometimes people think they're better off in this class than they are because they're able to follow me doing the stuff. I'm like, yeah, but when the exam comes, I'm not going to be doing it for you. You need to show me that you can do it. So I hope that you tried it. If you skipped that and didn't try it, because it's okay to fail. It's okay. I mean, it's okay to not get the right answer now. But if you don't try, that's a recipe for not succeeding in this class. Okay, so oftentimes the most difficult part is just getting started. That's true for math. That's true for writing, right? You're working on a paper, and it's like, I just don't know how to start it. I have all this information, but I don't know how to start it. For an artist, it's very difficult to start an artwork. For a musician, very difficult to start the song, okay? Even though you may have some ideas about what you want to do. Well, here we go. So let's do the 25th percentile first. Well, I know I want to get my x value, right? And here's my cumulative percentage. If, by the way, I saw 25.00, I would just go over and read the number and use the upper real limit and be done with it. I don't have 25 here. I mean, this is what I'm looking for, right? It's not on here, but I do know the 13.11th percentile. I do know the 34.43rd percentile. Those end up being my poles. If I know poles that surround my 25th, then I can get my 25th. Very powerful, right? Interpolation, very powerful. 34.43, how did I get this percent? It was 21 out of 61 people. How did I get 21? I had to get these 13, these 4, 4, and 4, 13, 4, 2, and 2. And so I need all of these numbers. I'm going to use my upper real limit for 6. It is 6.5, okay. And for my 13.11, that was 8 out of 61. That was these 4 plus these 2 plus these 2. So I'm going to use 5.50. There's another mistake that people make sometimes, and let me just use this example. So I'm going to use 6.5 and everything below it, right? And then when we get down here, sometimes people are like, well, shouldn't we use the lower real limit here? Because they think we're going in and taking a chunk like this, and that's not really what we're doing. What we're doing is we're saying 6.5 and everything below, 5.5 and everything below, that is the upper real limit here, that leaves us this chunk, okay? If we did 4.5 and everything below, we would have 2 chunks. That's not what we want, okay? So identify where you're at, use the upper real limit. Identify where you're at, use the upper real limit, okay? So we're set up here. We're going to use the same strategy as what we've used before when we did our 50th percentile, right? So I have an entire interval here. Let's see what that is, 34.43 minus 13.11 equals. So this whole distance here is 21.32. Okay, everybody got that? And then I went down a certain amount. So I'm going to do 34.43 minus 25. So I went down 9.43 over 21.32. That's a fraction. This over this distance over this distance. You got it? It's a fraction. And I know it's going to be under 50% because under 0.5, because that's less than half of that. Okay. All right. Over here, once again, we have a total distance of 1. I want to figure out how far down that distance, how far out of 1 is equal to 9.43 out of 21.32. Okay. If you got this far, you should give yourself a big fat pat on the back, okay? Because you've done it, and this is cool. You don't need to be ashamed of it. You don't need to be afraid of it. This is cool. This fraction, I want equal to this fraction. I know a little factoid here. Anything over 1 is itself. So this becomes the question mark. I'm going to do the math here. This says divide 9.43 by 21.32. So that's 0.44. Which seems right to me. And I always ask my students, when you get an answer, see if it makes sense to you. And I don't want to hear people saying, oh, how do I know if it makes sense? Listen, use your good brain, okay? If this was 10 over 20, you would know that that's half. So don't give up that information. This is 9.5 over 21 something. It's going to be a little under a half. Just a little under a half. If you can do that, you will do better on your exams because you'll know if you made some kind of outrageous mistake, okay? If you did this division and you came up with 0.87, I'd be like, what? That doesn't make any sense, right? This stuff makes sense. Don't lose control over the concept just because the numbers are a little bit more complicated, okay? So this is the 25th percentile, right? No, it's not. That's how far we have to go down to get to the 25th percentile. So we need to go minus 0.44, 6.06 is our 25th percentile. 6.06. Okay. So a couple of things here. Number one, if you got the right answer, good for you. Okay. If you got the wrong answer, good for you. Why would I say that? Why would a teacher say that? Good for you because you made a mistake, and if you can figure out where that mistake was and fix it, you will be better off in the exam. I get very frustrated as a professional teacher how upset students get when they get the wrong answer in class. I'm not worried about the wrong answer in class. I'm worried about the wrong answer on the exam. If you get the wrong answer in class, we can figure it out and see where you made the mistake. And believe it or not, you got to trust me on this one, you'll be less likely to make that mistake on the exam. Sometimes people get the right answer and they still don't know what the hell they're doing. That's what scares me, okay? I mean, one of my favorite sayings, even a broken clock tells the right time twice a day, right? Sometimes you get the right answer by mistake. You don't know what you're doing. So if you make a mistake, let's figure it out and we'll fix it. And then you'll be in good shape, for the exam. Email me questions, or you can ask when we Zoom. Let's do the 75th percentile. Okay. Let's do the 75th percentile. Well, we're going to keep this the same. The way you start these is the same, right? So this is how we're going to get our start. Looking for the 75th percentile. It's not on here, but I do have the 59.02th percentile. I have the 85th 0.25 percentile. 75 is in the middle there. See this? This is kind of cool, right? 85th percentile is 8. But remember, we got to use the upper real limit. Okay. 59 percentiles, 7.5. Let's get this entire distance. Okay. 85.25 minus 59.02 equals 26.23. And we went down, what is that, 10.25. Again, this is less than a half, right? A half would be 13 something over 26. So when I get my decimal, I have an idea that I'm in the right ballpark, okay? This is 1. And people are like, will it always be 1? I'm like, it's 1 when we use whole number successive integers, but we're going to do something in the next video where it's not going to be 1. But right now it's 1. It doesn't always have to be. It doesn't never have to be. When students ask those questions, again, I'm going to be confessional here with my teaching. When I hear students say, is it always that? Or is it never that? That usually is an indication that you're looking for a rule rather than thinking about the concept. Okay? Just saying. In this case, this is 1. And I want to go down the same fraction. So here we go. I know this is itself. Here's my question mark. Okay. 10.25 minus, divided by 26.23. 0.39. Okay. That's what we're going to subtract here. The answer, 8.11. Okay. That's our 75th percentile is 8.11. All right. Now, 50th percentile is the most common percentile that people will report. We'll talk about the three measures of central tendency, mean, median, and mode. And you've probably heard of each of those. So the median is the 50th percentile, the place where 50% of the scores fall at or below. Okay. 25th percentile, 75th percentile are also somewhat common, not as common as the median. I mean, the median, the 50th percentile has its own little name. These don't, but we're going to talk about these a little bit later in the semester. So we've done 50th percentile, 25th percentile, 75th percentile. We could also do the 13th percentile, the 27th percentile, the 93rd percentile. I mean, whatever we want to do, we can get. If we can read it directly from here, we can certainly do that. But I have the power of interpolation to get any damn percentile I want. That's just the beauty of it, okay? We're going to set it up basically, use your numbers to get your entries here, and then do the math, and you're good to go, okay? So that, I think we'll stop there because you spent some time doing your percentiles. If you have questions, email me, or you can talk to me during our Zoom meeting or whatever, okay? If you're so inclined, you can watch the video over again too. So anyway, we will look at another data set in the next video. We're going to get away from our happiness scores, but we have lots of descriptors for those happiness scores. We'll do another data set, and then we'll talk about how to do some graphs rather than these tables, okay? Try not to get overwhelmed. If you need to binge watch the videos again, you can do that. Work through the stuff, take notes. I mean, I'm going to ask you to be an active participant. If you're not, this course is very overwhelming. Also, when you're doing the math, think about the concepts, okay? Do the math, think about the concepts. What do the numbers mean? I mean, I'm going to ask you to be engaged. This is a challenging course, and I know that it is, but it's required for good reason. Later on in the semester, you will see we're going to put all of this together to do some really cool research. Right now, this is sort of the basics that we're learning, okay? But we're going to use these as tools as we go forward. Okay, I will see you in the next video.